We're going to learn how to perform nonlinear regression in MATLAB. We have a data set containing pressure, another one containing volume. We have an equation that we would like to fit to this data set. But let's try to understand what the rest of the inputs are here. You can see, V is the independent variable, P is the dependent. R and T, these are constants. And then A1 and A2, they're also constants, but they're the constants that we want to determine. We need to determine which A1, which A2 make this equation fit this data as best as possible. Okay? And so we're going to do that by looking at the sum of the square residuals. Now, the thing that's going to be nice is we're actually not going to need to take the derivative of this equation like we've done many times in the past week. Okay. Let's go ahead and write it. Q equals at A. We'll be referring to A1 as A of 1 and A2 as A of 2. And let's go ahead and start getting this in here. So this should be the sum just making a little bit of space in here of the square residuals. And all we mean by that is we're going to take the difference of these data points with what we get from this equation. Right, now we need to edit this a little bit. So this is all going to be a vector in here. Okay? And so that means if we're squaring a vector, we're going to need the dot. And again, if we're squaring a vector, we need the dot. Let's see what else. If we're dividing by a vector, we'll need the dot there. And if we're cubing a vector, we'll need to put a dot there. That looks pretty good. And we had to write it, again, using just A, not A1 and A2. So I need to fix that. A of 1 and A of 2. Okay. And we have to do that because we're going to use Fminsearch, which requires our function to be written in this format. Okay. So Fminsearch. And let's call since this is our variable here, let's maybe make the resulting A1 and A2 that we're looking for maybe lowercase a. Okay. So Fminsearch, we're trying to minimize, again, the sum of the square residuals. Let's maybe actually comment that in here. Minimize the sum of the square residuals. And I'm just putting in a guess here of 1, 1. If this doesn't converge to something that makes it fit our data, okay, then what we'll do is we'll graph this and see if we can eyeball where the actual minimum is for this. Okay. So right, we could create a 3D plot out of this. Next, let's start setting up our plots here. So let's maybe just plot the original data set to begin with. So how about we have plot V, comma, P, right? The V's were the inputs and P, these are the outputs. Okay? And since this is just data, let's use the asterisk. Let's hold on and let's start setting up another equation here. Okay, so let's maybe, when I go to plot our actual equation, I'm not going to only want 4 v's as the input, otherwise it's not going to be very smooth looking. So let's try v equals linspace from, and it looks like the lowest element in v is 1500 and the biggest element is 2500, and let's just do 100 elements in this vector. So there's v, and then let's write the equation for p, which should just be this thing right here. There we go. And just to edit it so that it's using the correct v here, I'm going to switch these all to lowercase v's. And also so that it's not using a, the variable, but a, the result from Fminsearch, I need to switch the big A's to lowercase a's. All right, and we have enough now to plot lowercase v, lowercase p, and let's give it a run. All right, let's see what we got going on here. Oh, easy fix. So I wrote 1500, but it should have been 15,000 and 25,000. Let's go ahead and run one more time. All right, and there we go. Seems to fit the data pretty well.